In this presentation, we're going to look at confidence intervals. So the question here is as follows. A random sample of 500 claims amounts. Let's actually just underline that. That's 500 claim amounts. Oops, that's a bit too big. Let's get that a bit smaller. 500 claim amounts result in a mean of 237 x bar is 237 and a sample standard deviation S of 137. Okay, so n here is a sample size 500, x bar 237, and sample standard deviation S is 137. Calculate a 95% confidence interval for the true underlying mean claim amount for such claims, explaining why the normal distribution can be used. Okay, the normal distribution comes from the fact that we are using the central, we can sort of rely on the central limit theorem here. And essentially, without getting too much into it, I'm trying to keep this short. Essentially, we have a large sample size here. And that, according to the central limit theorem, if we have a large sample size, assumptions based on the normal distribution can be used. So essentially, we can sort of tackle this problem on the basis that the relevant distribution is the normal distribution. So the confidence interval, point estimate. My pen is a bit funny here, so I got a new equipment and it's just training up. So that's why I got all these weird little lines appearing. So plus or minus, there's another one. Quantile times the standard error. Standard error. Now, the quantile, this is a 95% confidence interval. And we're dealing, we can assume the normal distribution of a large sample. So the quantile is just going to be 1.96. So the quantile is 1.96. Because it's a 95% confidence interval. Now, if you're not sure why 1.96 corresponds to 95%, this is not the place to deal with it, but it is an important thing. So if you're not sure why I'm able to say 1.96 just on the basis of a 95% confidence interval, there's a bit of revision you have to do before you get to this point. So let's go back here. The point estimate is the sample mean, x bar. Let's write this in here. X bar plus or minus 1.96. Actually, that doesn't look great. I'll just change the color here. I'll go with magenta. So it's 1.96. Now, the standard error is S divided by the square root of n. Now, this is a sample error for a mean. So if there is a one sample mean, so it's one sample and we're trying to find the mean. So this is the appropriate standard error for that situation, that we're looking for the mean and it's a one sample. If there's different sort of setups to the question, different standard errors should be used. We have all the information there. X bar, we know it to be 237. 1.96, we know. S is 137 and the square root of n is the square root of 500. So we actually just have to piece all the information together now. So let's try and do that quickly and then end this presentation. X bar is 237 plus or minus 1.96 divided by 137 divided by the square root of 500. Okay, now 137 divided by the square root of 500. The square root of 500 is 22.36. So working that out, I'm not going to do too much of calculator work here, but if we actually were to solve this part here, sugar. If we were to solve this part here, we get 6.12. 6.126. I'll just leave that as 6.12 or 6.13 even. So that is equal to 1.96 times, oh, that's 237, sorry. No decimal point there. 237 plus or minus 1.96. 1.96 times 6.13. We'll just call it 6.13. Just leave it to two decimal places. And that is actually should work it out to be just around 12. So I'll just leave it as 12. 2.37. Sorry, 237 plus or minus 12. Again, I'm just going for a very simple decimal place there, or just round it up to 12. So it is 225 and 249. Those are the upper and lower bounds of the confidence interval. So that answers the question.